Hello, minions. So before we start math today with something new, I wanted to review what we did last week. So last week we did coordinate geometry, and first we'll look at plotting points. So we have to remember that x is horizontal, so it goes left to right, and y is vertical, it will go up and down. Now, if I hold my pencil on C, it will tell you that the point is at 1 and 2. Okay, A is at 2 and 6, and C is at 4 and 4. Now, what we did last week was a translation or a slide. So I'm going to go translation, and I want the object copied. Okay, so there's our triangle, and I can move the triangle by just dragging the point. So if I drag A, there's my triangle. So at the top in the green, it says that I moved it 1 and 0. Now I moved it 2 and 0. I can move it down. Okay, and now it's 2 and -1, right? And, 2 and -2, I moved it. So then I could slide it around. So there I moved it 3 and -1. So I could put it back here, and I can move it this way. And now it's x is at -1, and y is at 0. Okay, so that's what we did last week. Now we're going to start a new canvas. No saving. There we go. And I'm going to do another triangle, right? So triangles are a little bit quicker to move. So I'm going to put the triangle, well, let's see, almost at the, well, I'm not going to say the same spot, but there we go. Now, if we'll review the points. So B is at 2 and 2, C is at 5 and 4, and A is at 4 and 7. Now, this time, we're going to do another movement. We're going to do what is called a reflection. Now, to do a reflection, we're first going to make a line of reflections. So here's a line of reflection is going to show up, and here it is. Okay, and I'm going to make the line of reflection here. Okay, I'm going to make it, there we go. So this line of reflection is at x is equal to 6. Okay, so it goes up and down, it crosses over 6. So x is equal to 6. Now, again, I'm going to make a copy of the shape. And we're going to flip. And there we go. That was pretty simple, eh? Okay, so if I look at the points again, okay, the original C is at 5 and 4. Okay, the image of C is at 7 and 4. Okay, so you can compare the original of the triangle. So this is the original A was at 4 and 7. And the image of A is at 8 and 7. Okay, and then finally, the original B is at 2 and 2. And then the image of B is at 10 and 4. Now, I'm sorry, 10 and 2. Now, to basically reflect the shape, we start off with the one that is closest. So it's not that hard to reflect. So for example, if you look at A is, I'm going to do a pencil. Okay, if this is the line of reflection, the line of reflection was y is equal to 6, right? So there's y is equal to 6. I'm going to make a line that goes up and down. So there we go. There. So that's the line of reflection, right? Now, basically, to reflect the point, I mean, you just have to remember that, C is 1 point away from the line of reflection. So then the image of C also has to be 1 point away from the line of reflection, okay? And then A is 2 points away from the line of reflection, and then it would have to be 2 points this way, right? So it's not that hard, okay? So we're going to start a new, well, actually, I'm going to erase a few things first. So I'm going to erase here, I'm going to erase my arrows here. Okay, now the next thing I'm going to do, I mean, I can move the triangle, and I don't know if actually, if I move the triangle, if the reflection point will also move. So if I move A, no, the whole thing moves. That's not what I wanted. Okay, that's fine. So actually, when we'll start a new canvas. No. And this time we're going to reflect along X, and we're going to do a quadrilateral, and I'll tell you what it means in a minute. So we're going to make 3 points. There we go. Hopefully you remember that's a trapezoid. Now we're going to make a line of reflection again, and this time the line of reflection is going to be here. Okay, so this line of reflection would be called y is equal to 4, okay, because it goes through the 4 along the y-axis. So we're going to flip it again. Oh, you know what? I want a copy of the shape so you can see it. So there we go, right? And once again, just like we did last time, you could see that D is 1 away from the line of reflection, right? So we can do that again. So I'll put my line back. Okay, so there's my line of reflection. And if I want to show you the line of reflection, you know, C is 1 point away from the line of reflection, and the image of C is also 1 point away. Okay, so it's not hard to plot. Now, A is further from the line of reflection, so it's 1, 2, 3. There it is. And the image of A is also 3 points away from the line of reflection. Okay? And we can finally compare points. So if I hold my, I don't know when this will work now. No. Okay. So if I, no, well, it doesn't work. Okay, well, we'll hold off on that. Okay, sorry about that. Now there is one more reflection that we're going to do. So we're going to do new. We're not going to save any changes. Okay. We're going to make a line of reflection that's, well, I'm going to say famous, I guess. So the first thing I'm going to do this time is I'm going to make the line. And where I'm going to put the line is along a special line of reflection. And I'm going to tell you why it's special in a second. Okay, there's my line. Now, the reason why this line is special, this is like a line of reflection that x is equal to y, right? So if I take my pencil, I'll even write it here. So x is equal to y. Now, you may think, well, what does that mean? Well, it's not that complicated. So if I look at like this point A is at 1 and 1. So whatever the value of x is, the value of y is the same. So B is at 4 and 4. Now, all the points along the line are the same. So if I, here is 2 and 2. Here is 3 and 3, right? So whatever x is, y is the same value. Okay? So 3 and 3, 4 and 4, right? So if I asked you, if x is 6, what's y? Well, 6, right? So whatever x is, y is as well. Okay, we're going to erase this, so it looks kind of sloppy. There we go. All right, but those 2 points need to stay, and I want to keep the x is equal to y. So the next thing I'm going to do is I'm going to put I'm going to make my triangle. Okay, so I'm going to plot 3 points. There we go, and there we go. So there's my triangle, and it's the original triangle. Now I'm going to do my line of reflection. So here's my, oops, sorry, it's the wrong one. Line of reflection. Okay, I'm going to set up my line of reflection along x is equal to y. So there's 1 and 1. I'm going to move the dot up here, and I'm going to make it, there you can see it's 6 and 6, right? So I basically put the line of reflection over the line that I just drew, or that I just put in, and put a copy of the shape. And then we're going to flip it. And then we're going to flip it. There we go. So now this one, it flips, and it flipped on a diagonal. Okay, and if you're visual, you could see why. Now, why is this line of reflection important? Why did I, save this one to last? This line of reflection, x to y, x is equal to y, creates something that's kind of neat. So first, if you look at the original C, C is at 1 and 3. Okay, remember that. The original C is at 1 and 3. Now, this line of reflection produces the opposite, right? So the image of C is at 3 and 1, There's 1 and 3. There's 3 and 1. So again, this line of reflection, x is equal to y, will allow the points just basically to switch, the x and the y to switch over, right? And then here's D. Okay, D is at, okay, think in your head what it is. Okay, I'm just going to give you a chance to think about it. Okay, hopefully you said D is at 1 and 7. Now, the image of D is flipped, right? And that's 7 and 1. And then finally, E, well, I'm sorry. Well, we can even show the coordinates. There we go. So E is at 3 and 5. And then the image of E is flipped, right? 5 and 3. Okay, I'm going to do that for all of them so that you can see it. Show coordinates. There we go. And then there's C. Okay. And then finally, there. So you could see that the coordinates flip, right? So if I take my pointer, so here is 3 and 5 for E, and then 5 and 3. Okay, and I think you get it. So there's 1 and 7, 7 and 1. Why does that happen? Well, it's this, because the line of reflection produces that result. This is a special line of reflection where x is equal to y, okay? And that's basically everything you need to know about reflections for this week. It doesn't get harder than that unless it flips over the shape, but we'll save that for another day. Basically, it just like last week, it reflects, but then it reflects and it will reflect and cover the original shape, right? Overlap. Okay, so then that's it for this week's video, and hopefully you find